Hello everyone. In today's lecture, we are going to discuss about ETL operations, which are OLAP operations, extraction, transformation, and loading. Here, data extraction means we are actually fetching or getting the data from multiple heterogeneous and external sources. We had already discussed about heterogeneous sources in the last lecture. The next step over here is data cleaning. So here we detect if there are any kinds of error present in the data, and then we rectify those errors. The third step over here is data transformation. We convert the data from legacy or host format to the warehouse format. Load over here, we sort, summarize, and basically we consolidate or aggregate the data and build indices and partitions. Refresh, here we propagate the update. It propagates the updates from the data sources to the warehouse. So these are the ETL operations. So remember that ETL, E stands for extraction, T is transformation, L is loading. Metadata repository. So the definition of metadata, basically metadata is the data defining a warehouse objects. So this metadata stores description of the structure of the data warehouse. So structure means, as you can see, a structure is composed. It means basically it can be a schema, view, dimensions, hierarchies, derived data definitions, data mart locations, and different types of contents. Operational metadata over here. So data lineage, it contains data lineage, currency of data, monitoring and information, monitoring the information. The algorithms are used for summarization. So we will see this in detail. So here we are moving towards data warehouse modeling, which includes data cube and OLAP. Now, from tables and spreadsheets to data cubes. So, we all know that data warehouse is basically based on a multidimensional data model, and basically it views data in the form of a data cube. So here data cube, one example is given here like sales. So it allows the data to be modeled, and it can be viewed in multiple dimensions here. So we are having two types of tables here: dimension tables and fact table. Dimension tables, for example, it can be item or time. So item, which includes the attributes like item name, brand, type, or time time contains day, week, month, quarter, year, etc. So, and these are the dimension tables. Next is fact table. As you can see here, fact table contains measures. So, what are these measures and how do we actually create these dimension tables and fact tables? We will see in the coming lectures. So, fact table contains measures such as dollars sold and keys to each of the related dimension tables. So, in data warehousing literature, an ND base cube is called as a base cuboid. The topmost, this one, as you can see here, yes, a 0D cuboid is called as a apex cuboid, a one-dimensional cuboid. Then we have a two-dimensional cuboid, three-dimensional cuboid, and four-dimensional base cuboid. So in data warehousing literature, an ND base cube is called as a base cuboid. The topmost 0D cuboid, which holds the highest level of summarization, is called the apex cuboid. And the lattice of cuboids forms a data cube. The conceptual modeling of data warehouses. So the as we have proceeded towards modeling, so modeling the data warehouses includes dimensions and measures. So here there are three types of schemas: star schema, snowflake schema, and fact constellation. So a star schema, over here a fact table is placed in the middle, and it is connected to set of n number of dimension tables. So as you can see here, this is an example of a star schema. We have a fact table here. This fact table is composed of measures. So measures are basically this thing. Measures are parameters by which we can actually compute something, or we can say calculate something. Like one example over here was dollars sold. Okay, so the definition of star schema here, a fact table is placed in the middle. It is connected to a set of dimension tables. This is the example of a star schema. As you can see here, we have a sales fact table which is having the key values of the all the dimension tables here. We are having one fact table placed in the center, and we are having four dimension tables. Okay, so the first dimension table is time, which includes all the key primary key as well as all the attributes present in that particular table. Second dimension table is branch. In that we are having a key, branch name, branch type. The third dimension table is item. Here we are having the key, item key, and name of the item, brand type, supply type. Next dimension table is called as location, and it is having a location key. It is having all the attributes like street, city, state or province, and country. So these are the dimension tables, and we have a fact table which includes the measures and all the keys of the dimension tables. As you can, and you can also see the arrows which are pointing towards the dimension tables. So let us see this in detail here. So here, this my sales fact table is having the first key as time key, which is taken from this dimension table time. That's why we have an arrow pointing towards this dimension table. The second key in the fact table is item key, and it is taken from the this dimension table item. The third key is branch key, which is taken from the dimension table branch. So you can see the arrows pointing towards this dimension table. The next fourth key is location key, which is taken from the dimension table location, and hence the arrow is pointing towards that dimension table. And we are having three measures here: units sold, dollars sold, and average sales. So this is an example of star schema. You have a single fact table, and there are n number of dimension tables, which are basically containing all the information of that particular table along with the keys, primary keys. Now, the fact table is containing the information of keys of every dimension table and the measures. So this was about star schema. Next type of schema is called as snowflake schema. So a refinement of star schema where some dimensional hierarchy is normalized into a set of smaller dimension tables is called as snowflake schema, and it is forming a shape which is as similar as the snowflake. That's why it's called as snowflake schema. So let us see one example of snowflake schema here. So this is an example of snowflake schema. As you can see here, we have a single fact table. So can you observe something? It is similar to star schema, but the only difference is that we are having a dimension hierarchy here. So so sales fact table is having all the keys of different dimension tables and the three measures here. We are also locating all the dimension tables over here, but the only difference between this star schema and snowflake schema, if you observe here, is the item here, supplier type, the item supplier type here. But in this, I'm just in this item dimension table, I'm just including the primary key of this supplier. So I'm basically showing the hierarchy that this supplier is key is taken from another dimension table supplier. Also over here in the next dimension table location, as you can see here, the country location is same city. Okay, the country over here or state or province is basically included in another dimension table over here, city. So one dimension table, new dimension table city is created, which includes the primary key city, the state name of the city, the province, state, and the country. And we have an arrow pointing towards this dimension table again. So one dimension table, okay, we are creating new dimension tables and we are showing the hierarchy here. This is called as dimension hierarchy. So this is the difference between star schema and snowflake schema. In the next lecture, we will see about this. We will discuss more about this. fact constellation, and I will also take few examples on star schema and snowflake schema. So, yeah, fact constellations are multiple fact tables, shared dimension tables. It is viewed as a collection of stars. So, it is also called as galaxy schema or fact constellation. So, in the next lecture, we will discuss about fact constellation, and we will take examples on star schema and snowflake schema. So, yeah, so that's all for today. Thank you for listening.